So now we're looking at solving a system of 3 equations and 3 unknowns, or 3 variables, using Cramer's rule. The process is essentially the same, but it's a lot more extensive because we have a 3 by 3 determinant for each one of the variables, and then for the coefficients for the equations as well. So we start with, we will find D, and we simply expand by the first column. You could expand by any one of the columns, but I'm expanding by the first column simply because it has a 1 in it. There's no 0, but there is a 1, and if you have a 1, it involves less calculations. So we want to pay attention to the signs, plus, minus, plus. So we have 3 times its minor is 5, negative 3, 2, negative 2. And then plus 1 times 8, 2, 5, negative 3. And that is going to equal 3 times 5 times negative 2 is negative 10, minus 2 times negative 3 is negative 6, so negative 10 minus negative 6, that's going to be 4. 10 minus, or negative 4. Negative 10 minus negative 6 is negative 10 plus 6, which is negative 4, minus 2 times, we have negative 16 minus 4. 8 times negative 2 is negative 16. 2 times 2 is 4. So negative 16 minus 4 is negative 20. And you can write these out if you need to. You don't have to use mental math. It's just a way to save a little room and make it a little bit quicker, but it would be prudent to write it out if you're unsure. And then we have 8 times negative 3, that's negative 24, minus 5 times 2, so minus 10. Negative 24 minus 10 is negative 34. And that's going to equal negative 12 plus 40 minus 34. And that's going to equal negative 6. Negative 12 plus 40 is 28. Minus 34 is negative 6. So now we're going to look at d sub x. And that's where we replace the x coefficients in our determinant with the constants. So our first column becomes negative 5, 0, 1. And everything else is still the same. 8, 5, 2, 2, negative 3, negative 2. And again, expanding by the first column, this time because we have a 0 involved. So again, same signs, plus, minus, plus. So plus negative 5 times 5, negative 3, 2, negative 2. Minus 0. I'm not even going to bother writing out the determinant because when we multiply by 0, it's just going to be 0. And then plus 1 times 8, 2, 5, negative 3. And I noticed a mistake here. I think I said it correctly, but I wrote it down incorrectly. Our constants are negative 5, 0, and negative 1. Not negative 5, 0, and 1. So I need a negative here. And how that's going to change this is it's going to be plus negative 1 times, and then what I had already written down, 8, 2, 5, negative 3 for our determinant. Now that's going to equal negative 5 times negative 2 is negative 10, minus 2 times negative 3 is negative 6, so negative 10 minus negative 6 is again going to be negative 4 minus 0 minus our 8, 2, 5, negative 3, that's going to be the same thing it was the first time, which is negative 34. And that equals 20 plus 34, which equals 54. dy will replace the y coefficients with our constants. So we have 3, 2, 1, and then negative 5, 0, negative 1, and then 2, negative 3, negative 2. And this time we'll expand by the second column since it has that 0 in it. So now we need to pay attention to the signs. They become negative, positive, negative. So negative, negative 5 is just 5 times 2, negative 3, 1, negative 2. Now we have a plus, but it's going to be 0 again. And then we have a minus negative 1. That's just a positive 1, so plus. And then 3, 2, 2, negative 3. And that is going to equal 5 times 2 times negative 2 is negative 4, minus 1 times negative 3 is negative 3. So negative 4 minus negative 3, that's negative 4 plus 3, which is negative 1, plus our 0, and then plus 3 times negative 3 is negative 9. 2 times 2 is 4, so negative 9 minus 4 is negative 13. And then that is going to end up being negative 5 minus 13, which is negative 18. And then last but not least, d sub z, we replace the z coefficients with our constants. So we still have 3, 2, 1. We still have 8, 5, 2. And then we have our constants for the z column. Negative 5, 0, negative 1. And now we'll expand by the third column again because that 0 is there. So we're back to plus, minus, plus. If we look at our... And I always write this up at the top of my page. So I have it there to remember. It's just plus, minus, plus, then minus, plus, minus, then plus, minus, plus on the bottom row, or you can do the same thing using the columns. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So expanding by the third column, we have negative 5 plus negative 5 times 2, 5, 1, 2 minus 0 plus negative 1 times 3, 8, 2, 5. And then that is going to give us negative 5 times 2 times 2 is 4, minus 1 times 5. So 4 minus 5 is negative 1. Minus 0, and then minus 3 times 5 is 15. Minus 2 times 8 is 16. So 15 minus 16 is negative 1. And that equals 5 plus 1. Minus a negative is plus a positive. So negative 5 times negative 1 is 5. Plus 1 equals 6. And now the process is the same as what it was when we were using two equations and two unknowns. So x equals dx over d, which equals, we found dx to be 54, over d we found to be negative 6, which equals negative 9. Y equals dy over d, which equals negative 18 over negative 6, which equals 3. And z equals d sub z over d, which equals 6 over negative 6, which equals negative 1. So tentatively, our solution, according to Cramer's rule, is negative 9, 3, negative 1. As always, in order to make sure of this, we need to check. So we'll substitute into our original equations 3x, so 3 times negative 9, plus 8y, 8 times 3, plus 2z, 2 times negative 1. Does that equal negative 5? So negative 27 plus 24 minus 2, does that equal negative 5? Negative 27 plus 24 is negative 3, minus 2 is negative 5. So it checks in our first equation. Let's look at our second equation. 2x, so 2 times negative 9, plus 5y, 5 times 3, minus 3 times z. We want to know, does that equal 0? So negative 18 plus 15 plus 3. That is negative 18 plus 15 is negative 3 plus 3 is 0. So it checks in our second equation. And last but not least, x. So negative 9 plus 2y, 2 times 3, minus 2z, minus 2 times negative 1. And we want to know, does that equal negative 1? So negative 9 plus 6 plus 2. That's negative 9 plus 6 is negative 3 plus 2 is negative 1. So it checks, thankfully, in all three equations. And we can officially say the solution to the three equations and three unknowns that we were given, that system of equations, is x equals negative 9, y equals 3, and z equals negative 1.